All right, I think we're finally good to go. Sorry for the short delay there. All right, so it's March 21st. We've got a few things to talk about. A couple of interesting things. I was putting together a test last night, and I've never seen this before. Due to an extreme weather event, LiDAR point cloud data is currently unavailable for download. That was new. Temu advertised this to me. This is from Amazon, but I'm eternally interested in building a large-scale autonomous rover. We have a small rover that you can program just like a drone, but you do it on the land. I'm looking for something bigger, and so robot lawnmowers are kind of like that, and electric wheelchairs are kind of at the forefront. But lawnmowers at least are like semi-autonomous. This one happens to just be remote controlled, but I know how to adapt to that stuff. So I'm probably not going to buy it, but I have to admit to being tempted. These are basically the motors that it is using, not this particular one, but something not far from it. They're basically the same thing as like electric wheelchair motors. So I'm still interested in this stuff. So anytime I run across that stuff, I'm excited. I got some news from, so Liam is in Peru with Brianna. Gianna, you 3D printed a terrain map for them. They loved it. So they were showing this to like the governor of the province that they were in. They were really excited about it. So your work is internationally renowned. Congratulations. And they were interested in the make and model of our printer and hoping to do something similar. So it was kind of a fun connection. I'm glad you shared that. I've been working for a while with getting sort of our best LiDAR unit operational. So a lot of times LiDAR units the best case scenario, LiDAR units get packaged with things that make them easy to use. So like the L2 LiDAR scanner that we use on the drone, that Liam has been practicing with, and hopefully we'll broaden that out so more people can get practice with it. It's sort of an all-in-one unit. You don't have to do much with it. You just sort of fly it and collect the data, and it comes back and you pull the data. The Ouster scanner is like the low level, like all I'm buying is just the LiDAR part of it. And so there's software, there's ways to combine it, but it's kind of lower level. I bought this tiny little, so for instance, it has no way to record any data. There's no data storage on it at all. It just like throws the data out, and then you have to figure out what to do with it. And so one of the things that you can do with it is just log it. Typically, you might like hook a laptop up to it and like log everything to a laptop, but that doesn't work if you're going to put it on a drone, right? You need the smallest possible data logger to log the data that's coming off of it. So this is a tiny little thing. It's about this big. It's called a packet squirrel. It's used in network testing to like log network traffic for further analysis. And so you just like plug the LiDAR sensor into the Ethernet port, and you plug a little USB drive in right here, and it just logs it out. I had the Packet Squirrel Mark I, the first round of this from many years ago, but it was only a 100 megabit Ethernet port. And the Ouster throws off way more data than that. So I needed something that had a gigabit connection, so I had to upgrade. It still is not, I mean, long story short, this is mostly just notes to myself. I did get it working. It's not super awesome. I'm not sure that it's logging all of the data. But despite the fact that it's great in the sense that it weighs, 15 grams, which is great for me for like drone stuff, it's proving to be kind of a headache to actually do the logging. So I don't know. I may still just do like a small Windows laptop for like on the ground mapping. It's like a Microsoft Surface tablet is super tiny. Or I might do it with a Raspberry Pi because I've got a lot more control over sort of how it works. Whereas this thing is a little not black boxy exactly. It's Linux, but like less easy to configure. Anyway, that burned up 10 hours of my life, probably more. I was working with Gianna to get the 3D or to get the bottoms for the meshes that we're creating correctly. We've both worked on this a lot over break. I guess a little bit before break, I had an idea as far as how to do this. So I got a chance to test some of the stuff out. The gist of this is when you run it through like Structure for Motion software, you get a mesh, which is like there's no thickness to it, right? It's just like the surface. Like if you draped a tablecloth on and sprayed it with hairspray and then lifted it off, it's just like this thin object. And so it doesn't print exactly. And so the question is, how do you make that into something that's actually printable? So the new idea was essentially to try to grab all of the outside edges, not the inside edges, or not the inside vertices, and then take those and sort of extrude just the edge part down and then make a flat bottom. So conceptually, it's pretty simple. But the idea that I had was, well, this is just a dissolve operation, right? From a 2D perspective, this is no different than a GIS dissolve. So you just dissolve. And now you've got the edges, which was weirdly the tricky part of doing this. And once you've got the edges, then you basically create a copy of those edges at a flat elevation. And then you start connecting up this vertex to that vertex and so on. And I've got a graphic of that. All right, so the idea is I've got vertices. So imagine that my whole shape is super complicated. I've got a million faces, but as I always say in programming class, like distill this down to the simplest possible case. So the simplest case here is a four. I've got four vertices: 0, 1, 2, 3. Because you usually specify it in either clockwise or counterclockwise order. So 0, 1, 2, 3 in clockwise order. And so then what I do is I take those and I imagine this in like 3D. I'm dropping those, creating a copy of those, and I'm dropping them down. So now they match up 4, 5, 6, 7. And then the trick is to connect them up. So Pix4D or whatever is already going to connect the top up. So 0, 1, 2 is one triangle. These are all triangles. 0, 1, 2 is this triangle. And 0, 2, 3 is the second triangle. So that's the top. And so the question is, how do I get the sides? And it works something like, oh, I see. There we go. So it works something like this. I connect the 0 to the 4, the 1 to the 5, the 2 to the 6, and the 3 to the 7. And then if you kind of unwrap this structure, it looks like this. So there's 0, 1, 2, 3. So I'm just kind of unrolling that top. And then below it are the vertices that match 4, 5, 6, 7. And so when I want to connect these up, I can do something like connect up 0, 4, 5, 1, 5, 6, 2, 6, 7. And so the pattern is pretty clear, right? It's like connect this plus 4. It's not quite that simple, but that's basically the idea. You got the one that wraps around at the end, but that's actually easy to handle. And then it's like one more plus that one, right? So one more over, one more over, one more over. So these are pretty easy to connect up. And then you do the same thing that gets us like these triangles. And so then you've got to do the other triangles. So that's those. And then you got to do the other triangles. So 1, 0, 1, 5, 1, 2, 6, 3, 7, right? So that gets you the edge. And then you got to do the bottom. And what my solution, and this is kind of like not a great solution, but my solution was calculate the centroid. Go back here. Calculate the centroid, and then just connect each edge pair of vertices to the center, like little pieces of pie, right? So over here, 4, 5, 8, 5, 6, 8, 6, 7, 8, 7, 4, 7, 4, 8. And that should be the whole thing. So this is how it really is. This is the mesh that we get out of like Pix4D or whatever. It's like that tablecloth that's been hardened, right? It's got a structure to it, but when you look at it from the bottom, you just sort of see the negative version of that. These are the edges that get calculated according to the method that I just described. And then this is the bottom that you get. Not so bad. Oh, and I was going to include a snippet of the code, and I didn't do that. So I've been weighing about whether to bring this in as an example into the programming class. This is just a straight NumPy calculation. You'd be surprised at how simple this is from the NumPy point of view. You're basically just like getting lists of things and like rearranging those lists. And so it's actually quite simple. All right, this one's for Dan. We had a good meeting on Monday with David Mixter. And one of the things that came out at the end was this question: how would you know that a given data layer matters? So most of these cost paths are slope based, but we're like, well, what if you added visibility or roughness or 100 of the variables that you might care about? How would you know whether that mattered? And I think I asked everyone to think about it and kind of roll around in our brains. And I had an idea a couple of days later that the degree to which a surface matters for a least cost path should be measurable by comparing the underlying distribution of the raster, the distribution of the pixels that match real paths. The idea is if your path is producing something that's sort of not reflective of the underlying data surface, then that's a good indication that it's doing something different, right? That it's selecting on particular parts of that surface and not others. And then the idea is that the effect size should indicate the strength of the connection. If you think back to your stats class, I've got pile of numbers A and I've got a pile of numbers B. And that if you run like a t-test and you want to say, is this different than that, right? You get a t-score and you get a p-value. You can also get an effect size, which is the magnitude of the difference, which is sort of a normalized difference between the means, right? So if the mean of this one is 10 and the mean of this one is 20, then that's a measure of the effect size, right? Like there's quite a difference between those two. So you normalize the mean effectively when you do it, but that's the gist. And so what I did to test this was just a simple test. This is why I was up late last night. I took a slope surface, a LiDAR slope surface for the campus area. In this case, I was going to do trails, but I ended up just selecting roads because I was like, well, those definitely are going to be on a flat kind of an area, right? Whereas the trails, like we talked about, like those aren't exactly least cost paths. You're sort of intentionally routing those up. So I didn't want to get into that immediately. I wanted a clear test case that was like probably going to turn out the way that I wanted it to turn out. So roads, I thought, definitely away from steep slopes when possible. So I grabbed the OpenStreetMap data for the roads and then loaded that up and then did feature to raster, which essentially like burns in those roads into a raster that's exactly the same as the slope raster. And then the code to analyze this is actually quite simple, right? So I'm reading that data in class today. We talked about like reading in values, right? So I've got a slope raster. It's just a big pile of numbers plus some header information. So in NeoPy, you can read that data in. There's a bunch of other ways to do this, but S is a 2D array of those slope values. R is a 2D array of where the roads are. The roads, when they got burned in with their, like, I don't know, some attribute that was in there. So I've said anything that's anything, just count it as a 1. So R is R greater than 0 means anything that's on there, just look at 1. And then what you do is you just construct a histogram. So plt.histogram of the slope data. And I said I wanted 50 bins, and I said I wanted to normalize it to density so that I could compare the two distributions. So that's in blue. So the slope values for that area around campus are in blue, right? There's like a lot of slopes between 0 and 10 degrees, and then it kind of, not so many above 45, right? That's a super steep slope. And then basically select the slope values where there are roads is this. Select the slope value where there are roads, and then plot the histogram of that. And you can visually see that those two histograms are different, right? So that's an indication if like I just picked random pixels out, like if these roads were just like randomly placed on the surface, then you would expect these two distributions to match. And so the degree to which they don't match is an indicator that something is going on. They are being selected for. And how do we test that? We could do a t-test. So the code down here is just doing a t-test. The t-score there is 107. That's crazy high. The p-value is like infinitely, it's not 0, but like it's 0.00001. And then Cohen's d is a measure of the effect size. It's really just a way of normalizing the mean difference. And so that number is 0.85 for, they have these sort of tables that say like how big is the Cohen's d is a big number. Well, this is 0.85, and that's about the largest effect size that you see. Now, those are scaled to whatever, but it's a big effect, right? Clearly, those distributions are different, and Cohen's d captures that. And the idea is that we could use the effect sizes to weight the combined models. So we've got 20 surfaces that we're interested in. We do this analysis. We sort them according to their effect size. And then we say, all right, well, like, should slope come out number one? Like, I would hope so. But what comes out number two? What comes out number three? And then you can weight them accordingly, right? Well, slope is 0.83. And the next thing that matters that we checked was like 0.2. And that becomes the weight. We weight slope by 0.8, and we weight the other thing by 0.2, and we write it down. What do you think, Dan?
Sounds good.
I think this will work. Keep pressing on it from your end. We'll see what David comes up with, but I think that this is a solid read.
Yeah.
All right. This is all the code that it takes to execute that, right? So it's not like, sometimes I think people think that like, you need 100 lines of code to do this, but you really don't, right? We're just reading the arrays. We're visualizing the data with histograms. We're running a t-test. We're calculating the Cohen's d, right? Like the actual code that it takes to do this. And they're all simple indexing values, right? It's just r equals r greater than 0, right? Like all of these things are really simple. So once you distill them down. I got my Guam report written. I was excited about that. I got that turned in last night. The bulk of that was done at the tail end of spring break. Just in time, because they emailed me like 2 days ago and were like, where's the Guam report? And I could say, here it is. But one of the questions that we had on this was, is there any way to process? So they went out and did a ground survey. So we flew the thing with LiDAR. They're supposed to do a ground survey at the same time. There wasn't enough time for that. So they went back and did a ground survey. They came back and they said, well, here's a bunch of things that we found on the ground, but these show up in the LiDAR data. I probably should have included a slide to show. They kind of don't show up in the LiDAR data, right? We found a foxhole here. Where is it? But one of the problems, and I've got a slide for this, is that the data is pretty fuzzy, right? So we flew a drone with like super close spacing, and then we flew it 4 different times. And the problem is that any minor spatial misalignment creates fuzziness, right? So if it's 10 centimeters off on this scan, and then it's 10 centimeters off on the next scan, because the thing is like jostling as it's flying through the air and all these other reasons, right? These tiny little mistakes, especially with the angle. So this is why the inertial measurement unit on a drone is so critical. All these little tiny minor changes in the angle mean fuzziness in the resulting cloud. So then the question was, well, we flew it with all of this stuff intentionally overlapped. What if we sort of like flatten that overlap out? What if we only, so the beam on the width of this thing is, technically it's 360 degrees. We usually take a 90-degree slice of it. But I said, what if instead of taking a 90-degree slice of it, we take a 20-degree slice of it? So now we're just recording what's directly under the drone. And so I sort of intentionally went overboard here to kind of illustrate like what you get is these strips, right? This transect, that transect, that transect. When I did it for real, I think I set this one to 8 or 5. So I set this one to 5 degrees on either side. The real one is 10, and that 10 lets you get to like, there's no separation between the strips anymore. They actually do blend together. But I thought this was good to illustrate the transectiness. We're just imaging what's directly below. You can also, so the way the scanner goes in space, it flies this way. So the head of the unit goes this way. So it's actually collecting 360 degrees like that. But also there's these beams, like some beams are directly below and then some beams kind of come out this way. So you're sort of getting this like rectangle of space as you fly. But you can say, well, this has 16 different beams that come off. What if we just take like the center 4 or 5? And so we're not getting all of these things that are sort of off in the distance. And so that's the narrow elevation FOV. So again, we're just trying to collect data from directly below us to reduce the fuzziness in the data. We only want to image a thing kind of once, which isn't exactly true, but imagine it this way. This is the fuzzy point cloud. This looks okay. I mean, nominally, I can create a 10-centimeter raster from this. You can certainly see individual trees like this. It looks okay, but that is what we do if we try to reduce the fuzziness, right? So we go from a pretty fuzzy representation when you see it the other way, you're like, oh yeah, that's much sharper, right? So it's definitely sharper. That much is true. What I hope that lets us do is like all of these little foxholes that we're trying to find that are like a meter wide. If you think about just sort of like smudging those things in the point cloud, like that's why they're hard to find. So we sharpen them up and hopefully they're gonna come out more clearly. The downside, of course, is that we're throwing away all this data that we collected, right? So now we're just looking at what's under us. So we go from 644 million points just in this point cloud to 74 million points, and we're just adding the step directly. So 11.5% of the data is what we're keeping, but it's sharper. So I don't know what's going to happen. The next stage of this is to actually do the part where we look for foxholes. But this is good to know. I mean, at least we know that it definitely sharpens it up. So that's indicative that we should kind of continue the analysis and see if we can get it. If this wound up looking like that, then we just probably stop there. So I finished my Guam report. That's been dogging me for a year. So I feel very good about that. My goal, if you remember from last week, was to do nothing else than to only work on the Guam report. So I failed that goal, and then you can see that I did other things that I shouldn't have. The next week, I'm going to try to catch up on 1,000 things, and then there's a lot of papers to be written. But it's nice to have this one thing behind me. Got it? You want to go next?
Sure. So I printed a couple of different things this week. I'll pass them around. This is how the campus map that Dr. Pringle was talking about came out. And then I'll pass the rest around as I talk about that actually. I'm gonna talk about all of these. This is actually the code. So
Oh, there it is.
but yeah, he talked about it, so I'm not gonna go in depth. I can't explain it as well as he could. But yeah, essentially grab the external vertices around the mesh that we had, brought them down to a flat plane. So that was cool. And it wasn't that long. And yeah.
And pretty messy.
And okay. And then when I came back from break, this was actually the first thing that I printed. And there was some error message that occurred. I looked it up. This guy said that after 3 attempts, like you just restart it 3 times and it was fine. That's exactly what happened. It was essentially the Z-axis couldn't raise the bed all the way up, and I was getting a little concerned about it. But we just retried it and it worked. I don't know. I think it was like calibration issue from not using it for a week. But
Oh wow. Okay.
I don't know. It's fine now. Hasn't come back. So
A disturbance in the force.
disturbance. But yeah, I don't know. That's what happened. And then for the glue, I wound up printing this really small replica of Mount Rainier in Washington, because I wanted to test how sturdy the glue that I bought would work to glue pieces of things together. It worked really well. It dried in like 30 seconds.
Wow.
And it was super strong. And you can kind of put pressure on both sides; they don't come apart.
Yeah. So that was printed in. I saw it on the printer. It was really cool. It printed in 2 pieces.
Yeah.
And glued together. So it looks like a whole single piece.
I didn't glue it back completely flat because I messed it up, but it was flat. So.
Does it let you? Is it sort of like sometimes like crazy glue is like the instant you touch it, it's kind of like stuck with it like that.
But like you have like a couple seconds of leeway to like manipulate it. That's why it's kind of like I don't know, comes around to be like it's gonna be like a little angled. But
Maybe if you had like a, well, like a jig, like something that
yeah,
like
that just
lets you
presses
slide
them
it,
together.
right?
But I don't know.
And then what if you had like parchment paper or something so that like you didn't have to worry about the glue kind of spilling, you just like
It might
glue
stick
it.
to the parchment.
think
I'm
so?
not really sure. It's like really strong glue. It reminds me of like nail glue. I'm assuming you've never used it, but
Is that the glue used to?
yeah. But it's like very strong and it's very fast.
Oh, you think nail glue would work?
Good. I'm assuming it's probably like the
Well, I'm
same
glad that
thing.
this worked. I tried a lot of glues and never had anything work, so this is good news.
Yeah.
Cheap stuff, like $5.
Yeah, it was like 5, 6, something like that. And then Dr. Finkel asked me to look into if there was some sort of like common ratio that people use to 3D print, like cityscapes or like campus essentially. Because there was this film that was, or a couple of films used like sets to film like decoys of areas, and that's at a 1:87 ratio. I found out that there's not really a single one that people use, but it's pretty much between like 1 to 500 to 1 to 1,000.
Okay.
But it's nothing like super specific.
Okay.
But while I was looking into that, I found this like website that you can like outline an area and then 3D print that, which is essentially what we're doing with campus. So I kind of want to try it with
Yeah.
campus, see if it like, because when you scroll down, it like registers as flat plane. So I almost wonder if like slope isn't included in that. So
Oh,
I'd like to just look into that, and then
yeah.
same thing with Google Earth. I need to do that as
Yeah.
well.
Okay.
And then when I printed out a world map file, it's actually the same thing that's over there. But I wanted to print it out again over here. It did not work. The bottom layer just didn't really print. I think because it's so thin, it's kind of similar thickness to this. It just didn't like register as a layer. But I'm pretty sure the fix will be pretty simple. I just have to put it into Fusion and extrude it.
I will redo it for you.
Okay.
Yeah, I didn't do it right.
Okay.
I'll re-prepare it.
So yeah, I just gotta print that. And yeah, so I also loaded into Drone to Map like before break, the old Johnson flight data. And I wanted to reconstruct that and export it as a mesh to see if I could try to get it to print here. I wound up not being able to do it on Drone to Map, so I tried on Pix4D. It took forever to load, but then I tried to export it as an OBJ, and for some reason I don't have the right edition, so I just need to like look into that. I think I might have just downloaded it wrong. But yeah, once I do that, I can download the mesh and try to print that. So next week I need to finish up my touch terrain prints. I'm printing one right now. That's from my big 8-panel map of the area. I'm gonna try to recreate the campus vertices extension thing, and then export the old Johnson mesh. I talked with Joanna from ETS. She got me in touch with this guy named Jake, who's gonna be the head next year. So she wants me to like kind of collaborate with him from now on. I'm gonna meet with him on Tuesday. See if I can try to discuss if the campus map could be recreated in Blender or something like that.
Okay.
And then look into the Cura website and then Google Earth. I just forgot to write it.
Awesome. Thanks. One of the cool applications I think with Blender is like making edits, right? So a lot of times in geography, we're mostly interested in modeling what is there, right? We're mapping things, what sort of implies we're mapping things that exist. But when you're like exploring scenarios, like what happens if we tear this building down and do this with it or do that with it? Like that's an interesting example of sort of like using partly real data, but then partly generated data. So.
Yeah.
All right, thanks. So,
Okay, so I'm gonna start off with some photos of the week. Buckland and I were able to go a couple times over spring break to collect some data. We used a different way of collecting the PFM1 mine imagery, and that is with a fishing pole that Dr. Holo lended us. It's on the back table there if you want to take a look at it. So yeah. Did we hook it up correctly?
Yeah. It's my travel fishing pole. It comes apart. It's in a tiny little bag. It's lovely.
Where you go traveling with your fishing?
I fished at the park once, so I just put it in like a little bag and then.
For some reason, I thought like you took it in your suitcase and like you went international with it.
Ah, that'd be nice.
But
Go
anyway,
fishing in the rivers of Spain or something.
so we collected data in near CIW Woods. We collected bare grass or bare ground and gravel. I tried to take some of the cans that I had requested. Thank you everyone for doing that, and I crushed them up because I don't think, I mean, in my mind, typically they're gonna be crushed instead of like, fully. So that's what I'm doing here. So Buckman, and this, I think in this case, he was the one with the fishing pole. And I think it worked out okay. I don't know if Buckman felt the same way about the fishing.
The idea was it was gonna be a simpler way to like manipulate it, right? So one person can like put it to a new spot, put it to a new spot, less.
Yeah,
It's right.
we did have one, I think one drone flight where we didn't use the fishing pole. I think we went on the 12th and we weren't like ready to do that, but we were able to like test it out, which was fine. So again, these are different images of the PFM1 mine. This is like the gravel in this case, it's the woods. You can see on the left there's a little bit of the PFM1 mine included in the image, and then a very zoomed in image of the PFM1 mine again. So I haven't started to label the data set yet, but that's gonna be something that I'm planning on doing this upcoming week. And I think I need to start to close off the data collection portion. I'm at about 5,700 images. It'd be nice to get to about 6,000, just like a nice full number. So maybe I'll do a couple more flights, specifically with the Autel. I don't have as much data collected using that. So that's the plan, depending on the weather. The other thing that took up my entire spring break was in the geology department or the earth sciences department. Me and Colin, if you've heard of him, we've talked about him a little bit before in the lab, and 3 undergraduate students participated in something called the Imperial Barrel Awards. It's this international competition where you're given real data set that has been heavily modified that an oil and gas company has collected, and you are essentially trying to use the skills that you've learned to determine if there's a presence of hydrocarbons, which essentially means there is a presence of oil and or gas. So we presented yesterday, 9 a.m. I think over spring break, as I've mentioned to you, I've spent over 80 hours on this project, so I'm very, very glad that it's done. So these are just a couple of slides of what we did. So I made those maps that you see on the right there. They gave us the data, so we have seismic data, we had to interpret that, we had well log information. That information is pertinent to understanding, what type of rock deposition is there, and that's going to correspond to whether or not it's able to preserve the potential oil or gas that's in the area. So our area was in northern Spain. It's called the Ayo Luengo field, which you see in that red box there. And we had 2D seismic data, which is very sparse. It's kind of hard to tell from here, but our seismic data, which is what a lot of our interpretations heavily rely upon, were kind of garbage actually. But we were able to make it work. So when you are analyzing the data that is given to you, you basically come up with something called a play, and there are different elements that go into it. So when you're trying to identify the presence of oil and gas, you have to think about different things, including the reservoir. Again, this is all related to the different types of rock deposition, the source of the rock, and then the seal. All of these things pertain to whether it can trap or seal the oil or gas within the area. So we came up with our strat column, which you see on the right there, and it's called the Jurassic Play because it was mainly around that time period where we saw a lot of sandstones and shales, which are really great for captured oil and gas. And then we have something called a kitchen map. So essentially, when you are trying to determine whether there is presence of either of these two items, you have to use something called the geothermal gradient. So you're looking at temperature through depth. And there are certain windows where you're going to see oil, gas, or if it's immature or overmature. So on the map that you see to your right, you have these 3 polygons. There's one in the middle, sort of, it's kind of tiny. And then you have 2 on the southwest corner there. So these were prospects, so these were areas within our study area, so that entire polygon where we have identified that there is potential for oil. So our field, we were again trying to focus on the oil, because that's typically what the judges were looking for. So these 3 were called prospects. So that we also made. And then we're basically taking a closer look at each of our respective prospects. So this is one in the southwest corner. So this one was called Cascadia. We came up with the names. We have something that we created called an isochore map. So you're looking at the thickness between the reservoir rock and the seal rock. So you want it to be thicker. That's generally better. And then on the right, you have the structure map. So basically you're converting 2A time into depth, and that's a calculation that you do in ARC. But essentially the darker or the lighter the color for your right-hand map, the better. So this is one of the prospects we've identified. And then you see something in the text box within the map, which is called Huntsman 1. So these were wells that were drilled nearby. So we typically want seismic lines, which you see in the red on the right map, and you want a well nearby to support your decision that this is a potential area that you should drill in. Yeah, so this was a like 40 slide deck presentation that we had, but I just took some snippets of it because I didn't want to bog you down, and I also didn't want to relive that trauma again. So yeah, we are waiting to see whether we have moved on to the next stage. So we competed yesterday with the region, so that was within the United States and Canada. And we were competing against like oil universities like A&M, University of Georgia was also participating, Rice University, Colorado School of Mines. So they haven't said anything yet. They did all of the judging yesterday for all the different schools. I think there were 7 in total. So we're waiting to hear back, and if we have moved on to the next step, then that means on May 1st, we do another presentation of what we've done and see what we get. But I think we've had a pretty good track record. In 2019, Binghamton University placed 3rd globally, and then in 2022, we also placed again 2nd globally. So we'll see what happens. We're waiting to hear back for what they say.
Good luck.
I'm just glad it's over. So my goals, because again, this past week I didn't have a lot of time to focus on my thesis. I have a lot to catch up on as well. I definitely have a lot of writing to do because I have a defense presentation date now, April 28th, I think. Again, I need to collect the last leg of my data. I think it'd be nice to collect with the Autel. There might be room to do GoPro here and there, we'll see. Again, I just want to round up that number to about 6,000 images. Begin the outline of my defense presentation. I think typically people are breaking it up into chapters. That's how I've seen it done, at least in the sciences department. And then I have to finish labeling the 5-meter Oklahoma data set, which I think is gonna be not as bad. And then finally, I have to really work on debugging the testing syntax for the YOLO v11 version that I've been working with. So YOLO v5 is a different way of writing out the command to test your object detection model, and YOLO v11 is one that I've been putting off, but I think now's the time to start working on that.
Okay. Cool, thanks. Okay.
Yeah,
That'd be good.
might take a second. Yeah. Alright, so this week and kind of over spring break, I was just kind of going through the trail camera data, manually importing that into Excel. And also I fixed up my aggregated drone file spreadsheet as well. So just kind of sifting through the data a little bit more and just continue processing the data as much as possible. And then obviously analyzing it. So this was kind of cool. This is in the nature preserve. So there was actually like a herd of 7 deer, which
Wow.
now I'm kind of like thinking to myself, like, is it the same 7 or 8 deer that I saw on a flight one of the flights that I recently did too? So kind of wondering about that. Maybe that's there. This, while it's kind of funny, like I think this could be like because like deer mark their trails by their pellets. So I was like, this could like be some useful information. I'm not like, I'm not obviously like an animal or wildlife biologist who knows like really what's going on, but like maybe that's an instance of that, or maybe he's just going to that, but you know. Then there were some trail camera anomalies, like this happened again.
Again, oh, has this happened before?
Yeah, because I think because the time it's at 6 a.m. so I think it's like shifting from
Oh, yeah, okay.
yeah. So I think that's why that one looks like that. But then trail camera 5 also got a lot of captures just because there was like a branch swinging in front of it.
Bummer.
So yeah. And then there was like a random skier in CIW.
Cool.
Which I was like, wow, I didn't know you could ski in CIW, but
At night, what time is that? Is that time accurate?
yeah. Wild. But yeah. And then a lot of yesterday was me prepping for data viz. So potentially doing a lightning talk. I was when I filled out the proposal form, I did put it for a poster, but hopefully I'll get it to be able to switch it to lightning talk. And but oddly enough, in the proposal form, they didn't ask for like any like PDF document or anything. So it was just like kind of like a description of what you're doing. But
Cool, thanks for coming in.
But mainly with this is like a draft presentation, so this is gonna like kind of help me like outline my defense presentation as well. So if you guys have any recommendations, just like kind of feel free. I have like questions at the end for you guys, so. But yeah, so this is like the title slide. Maybe I'll change that later, but remote sensing techniques to assess what kills your population. And then table of contents, intro, background, preliminary research, and then I made a section for refined research because we like kind of updated things later on, and then some findings and discussion and conclusion. So here's an introduction to your problem. I don't want to like have you guys sit here because like, you guys heard this a lot, but
When is the real thing?
I think it's like in May 15th.
So you've got some time. Okay.
And then contributes to forest understory, all that kind of stuff. And then some background information. Deer went nearly extinct almost a century ago due to overharvesting. European settlers had a high economic value on them, and then wealthy hunter clubs like the Texas King Ranch spearheaded deer preservation efforts. Combined with federal legislation acts, deer populations climbed rapidly. And by 2013, they were already at 30 million, and they continue to grow today.
Can I give you feedback as you're going?
Yeah.
So I remember you showing a really good graph that highlighted this.
Okay. Yeah.
You remember that?
Yep.
I think that's probably like this is a lot of text for a data viz presentation. So when I gave a data I mean everybody's different, but I tried really hard to avoid any text at all and just have images and then talk about them, which is not how I give like a lecture in class. But because it was for data viz, I was like, let's take as much text off the table as we can and just focus on the graphics that tell the story.
Yeah, I saw that graphic, so I can do that instead. And then just background on remote sensing, why remote sensing is good for wildlife, all that kind of stuff. Talk about introduce trail cameras a little bit and drones. And then my research questions, like when compared, like what remote sensing techniques are the best for monitoring white-tailed deer populations consistently over a long period.
I really like the organization into these like chunks. That's visually nice.
And then how have deer populations and behavioral patterns changed in relation to 3 polling events? And does data on vehicular collisions support these assessments? So those are kind of where my research questions have evolved to. And then this is just a slide showing my tracking methods for deer. So trail cameras, UAV flights, deer trails, and deer tracks. My only thing with this slide is like I kind of feel like because like the first 2 images aren't ones that I took, obviously. So I'm like kind of curious, like maybe they should just all be like pictures that I have taken.
It's better if you can.
Materials, I don't really like this slide yet. I need to figure it out because like I kind of want like the Mavic 3T to line up with where the Mavic is actually at, not just have them everywhere on the slide. But yeah, definitely good to bring up materials at least at some point.
I've got an extra 2 dangling on the SRT trail.
And then this slide I kind of like. This is talking about the preliminary research, how I was doing automated flights, fully automated flights over the nature preserve at first to capture thermal and RGB. I made a little GIF yesterday, and I'm like talking about how it's like this one's kind of talking about more like how it's difficult to identify deer because that clearly looks like a deer, but when you like zoom in, which is shown on the next slide, like it's still not very clear that that's a deer.
The images seem a little grainy.
Yeah.
Is that when you're doing the GIF transformation?
I don't think so. Maybe I could like raise the quality up, but I think that was just how the images
They're just like that.
they were just like that. And like yeah. This is just more to emphasize like this is what I tried first and this is why it really wasn't working that
Right.
well.
The other one I think is pretty clear. This one I think is particularly blurry. So
Yeah, because this one's the same picture, but just like zoomed in a lot.
I see.
And then talking about the refined methodology, doing semi-automated flights, when a potential deer is spotted, pause the flight, zoom in, capture videos and pictures. And then talk about how that still maintained the integrity of the missions. It didn't change how like the flight paths were defined or anything like that. And then talking about how at this point I also decided to install trail cameras throughout it, which was maybe show that map then or show it earlier, because that's kind of the study area map, but yeah. And then showing the obviously showing pure data captured to kind of like try calling that this made the research a lot more effective, easier to do.
Yeah.
That's why it's definitely more powerful to do a presentation.
Yeah. I think that's right. Yeah, you wouldn't get any of this on the poster.
And then going into some preliminary results of the deer population density charts like this one. And then, oh yeah, I had these back to back because they're UAV flight based, and then next is the trail camera stuff. So I just kind of showing what the trail cameras captured. Interestingly enough, the one in CIW has been kind of having battery issues, but I have the solar camera, like I think something's wrong with the solar panels, I have to go back and fix it.
We're winding down data collection anyway.
Yeah. And then DMV versus trail camera charts. So this is kind of the first one that I thought of. Just
Wow, I haven't seen this yet.
Oh,
Right.
really?
I don't think so. Trail cams versus deer collisions?
Oh, that might have been the lab meeting you weren't here.
Oh, maybe I missed it.
Yeah, that might have been, so this one is just the normalized trail cam deer activity versus the normalized deer collisions. This, I believe it includes Binghamton and Cook County data. So just showing those showing those two lines side by side. And then the kernel density map. Something's gotta be shipped around, like organization's gotta be fixed. And then discussion, conclusion, wanna figure that out a little bit more, definitely hit home that the deer are destroying the forest, understoring the preserve. This year's polling events were the most successful, killing 50 white-tailed deer, however, the population seemed relatively unaffected. And the nature preserve may be a population sink for deer populations.
So we still need a graph for like probably like trail cam is gonna be the best data, I think, for like population over time, like, there's this many and then theoretically like the culling and then seeing it rebound.
Yeah.
eventually.
Yeah.
That's an important slide, okay.
And then these are just kind of some questions that I thought of on while I was making this, like I was thinking like, should the nature preserve like kind of receive its own slide, because like give some background on nature preserve, how big it is, why deer are overpopulated, how it's talk about the deer fencing in the nature preserve, like kind of things like that. And it would be a good way to introduce the culling events as well, which I didn't do. I mean, this is just.
Yeah, this is really good that you've got it this far. I think I would probably recommend. All of this stuff, like history of nature preserve, would be great for like your thesis defense, like absolutely go into it there. I would say for the lightning talk, lightning goes by fast. So I would try to get it down to 10 slides of mostly images. Would be a good target for that. It's great. Good work.
Yeah, and then all that kind of stuff. And then goals, definitely write my methodology, draft, like this kind of sort of the start draft to also the defense presentation and lightning talk. And then collect the trail cam data again, and maybe potentially do 2 or 3 more fights. It's not really necessary at this point. And then go like really hard into a lot of data analysis and getting some finalized products.
Very good. All right, thanks, Peter. Do you have to leave soon?
No.
Oh, good. Okay, great. I know we wanted to schedule some flights on it to make sure that we got that in before you had to go. So very good. All right. You gotta go?
Yeah.
Yeah.
Yeah, you wanna.
So, this week, trying to get a reconstruction from the new, but I've not been successful yet. The first one I tried, I think it was with the camera model parameters. Like a pen go myself and then Lana went through it to kind of try and fix it. And I tried it again and it still hasn't worked. I don't know why.
So you got 58 images that you collected with a 3-second time lapse. The thing
Yes.
can do a time lapse?
Yes, so I collected 58 images with the time lapse, 3 seconds from the grad office, the graduate office. So I set the time and I was flying pretty much slowly so that I can get the overlaps, which I think it was good, but I don't know why reconstruction is involved.
Can you set the time lapse any faster than 3 seconds, or is that the limit?
No, we can say faster than that.
Like 1 second?
Yeah.
Can you set it any faster? 1 second is the fastest?
Yeah,
Set it for 1 second. Always better to collect more images and then just like deselect the ones that you don't want. Yeah, you want to oversaturate on that. If you could get it every half second, I would even do that, but 1 second is okay. Yeah, great. I didn't think I could do that at all. How do you do it?
I just Googled it and I was like, oh, if I'm to fly and collect the images at the same time, probably I might miss it. So let me try and see if I can
Yeah.
collect it all to this
So do you have to like do it on your phone, or like how do you
No.
set it up to do
on
the
the controller.
controller?
Yeah.
Yeah, nice and easy. Oh, that's great news. Okay.
And then also, this is for the GIST project. I'm currently working on code violations for 2024. So I did a map for 2024, but I realized that 2016 to 2024, they don't have any time series data. So I decided to do something about visualizing temporal data. So this is about code counts, violation counts per parcel from 2016 to 2024 in time series. And then as at the time I was doing this, I didn't have access to 2022 and 2023 data. So I kind of couldn't get that fixed in, but now I have access to it. So I'll go and update this and then fixing this. And then the tutorial on there was quite useful to me, so it kind of helped me with this visualization.
There's a way to do like space-time analysis. Maybe we can chat about that next week. I think might be kind of cool.
And then the finger pointed me to this blogspot by Mark. So I tried looking into it, and it was about supply data from SatLogic. And this is a company that was founded in, well, they have in 2013, they have offices in North America, South America, and Europe, specifically Spain. And then currently, they have about 24 satellites that images about 80% of the world's land every 2 weeks. And then with their capital expenditure, they actually mean that their data could be far less expensive compared to other industries. And currently what they are doing is that they've launched the Mach-V series, which was launched in 2022, and currently we have about 7 of those orbiting the Earth. And this Mach-V series have a 70-centimeter resolution, which I think is okay, just that not so much okay with the Mach-Z, which is about 30 centimeters. So the next thing I want to do is I want to compare this with that of the Mach-Z and look at which of them have their pros and cons. Yeah. So there's more specifications about their data and how you can get access to it. So I also want to get some sample data from this and try some reconstruction with it. Just that I have not seen them collecting DEMs. It's more of RGB and then near infrared images to me for orthophoto, but not for 3D reconstruction.
Okay.
And there's some of their sample data, which is quite good. And I came across this talk from geography realm, where they were asking where GIS professors are hired from.
This is great.
Yeah, and it's a research that was done by Professor Yuhan, and then Shen from Texas, and then Wisconsin, respectively. And then they are trying to look at which institutions are GIS professors hired from.
Yeah.
And it's kind of like most of them are either hired within their where they schooled. So it's like there's a regional bias when it comes to the United States and then Canada. And Yeah,
Okay, does anyone know?
maybe. I think it's UCSB.
Okay, Santa Barbara.
Yeah, so it's kind of. I think that the reset might be correct because. Yeah.
I'm surprised that Penn State isn't higher.
Hmm.
Buffalo is quite well represented. And Ohio State as well. It's interesting.
So that is all, and so like for my goals, like I said earlier, I'm trying to visualize, I'm going to add the 2022-2023 data to this and try to visualize it. And I was also thinking of maybe I was doing something right with the new images, so partner with Alana to figure out what exactly is going on. Yeah, I also do a comparison of the Magza and psychological data. And there's this article it's a chapter of the book that was written by Dr. Adams and then another professor where they are looking at examining the 3D urban delta volume using LiDAR and then radar. So I'd like to read through this and figure out what exactly is happening. Yeah.
Well, yeah, good work.
Thank you.
What? I don't think I ever really looked at it.
All right.
We did a really like chill week because of being with textbook stuff. That's gonna run through them. So my major struggle is what led me to start learning JavaScript. So the last time I mentioned how basically I was successfully added images to my map and I was able to do it as a pop-up with my Polygon. But when I tried to add multiple in a slideshow style, it just didn't work and the code became like really lengthy and weird. So JavaScript could be a good way to do this. Dr. Bingle recommended this book, so I've been working through it. So I've been working on chapter 1 of the textbook. So basically, it's just like getting started. It's very similar to HTML because a lot of it's integrating with HTML. Figuring out like how to like integrate Java into it was a bit of like a learning curve, but I really enjoy it. And another thing I had to learn out is the console. So if you know like on Google, you can like inspect the site. If you press like next to it, there's a thing that's console. So basically, in the code using Java, you can write like messages. So it's another way to like have your code run. And then I also learned how to basically write a JavaScript and then add it to a page like separately so the page doesn't get too long. I'm absolutely integrating this into my leaflet file because I don't know if you guys remember last time, it was like over 100 lines long and that was just one part of it. So I'm very excited about that. And in future goals, I'm going to continue working through the book and then figure out how to implement this in my leaflet code. I always work in the beginning. I did watch Severance last night, so I'm excited about that. So that's all for this week.
Awesome, yeah, thanks.
It's been a few weeks, so one of the things I was working on last time was accounting for projection errors, in path calculations. So I got the model working, I was troubleshooting this last time, so it was this random person on the forum that detailed the way to do it with the Mercator projections, so I just kind of took the method from them and worked it into this. So I ran a path calculation with Hilbert's hiking function and water barriers with a 50-degree slope cost. That's just what I was doing beforehand. You can see the adjusted path is in blue and then the non-adjusted path is in purple. It's basically the same. There was a bit of a diversion, but it wasn't super far apart. So this tells me that in stuff like this, it's probably not too important to worry about distortion. Which is a good thing to know. So.
Yep.
So that went well. Also using the corridor tool. So I ran it with the same settings, and the interesting thing with this tool in comparison to what I've been doing before is that you can select multiple connection points and have the tool run on all of them all at once. Whereas with the one I was using before, you need your input point and you need your destination point, and that's really it. You can also set it to use line or polygon, and it will create a path from the most optimal point along the perimeter, along the length, along the length. You can also choose a width for the corridor to be. So in the photo there, no width is in blue, and then the 5 meter width it's in orange, and you can see that there are some areas where it actually differs. So that's saying that you want your path to be 5 meters long, which means that it will be multiple raster cells wide, and so that can change how it calculates the path. And then the other interesting thing is that you can also show neighboring connections. So those are right there. So within the network, you can have connections to multiple points, even if it's not the closest one. And that will be the most optimal path to get from each node. So I think there's some interesting applications there, but it's still kind of limited to what Arc can do. So
what tool, how is this executed versus, like, it's a different tool?
yes, this is optimal corridor connections.
Corridor connections.
I played around with it a little bit before. I found that the results are pretty similar between them if you're running them with similar settings. It's not totally clear to me how this actually operates in comparison to the previous tool. There are no like distance accumulation back direction rasters that it produces. At least not that I can access while it's running. So it's a bit of a black box, which is why I haven't been using it as much up until now. But I think it is still worth investigating a little bit.
In the other tool, can I do one point to many points?
I'm not totally sure because there are options for network connections. I haven't really played around with that at all. I think I was trying to get that to work like at the very beginning, and it wasn't for some reason, so.
Okay.
It's possible. But, so that was that. So the other thing that I've been working on, or was working on, was trying to calculate, a raster of linear slope from a point, or more realistically, using linear slope in cost calculations instead of aerial slope. So I had to do this in Python because Arc doesn't have a method of doing it, but the idea behind this was to kind of recreate the way that Arc's tools work with a cost accumulation raster and a back direction raster. But instead of feeding a value from a slope raster, the idea is to calculate it based on the cell that you're targeting and then the 8 surrounding cells. So depending on what direction you're moving, it will do a different calculation with the elevation value of your input cell and then the specific neighboring cell that you want. So it just does rise over run and then turns that into a degree slope value. And then it takes that degree slope value, puts it into the cost function, and then it writes it to the cost raster if there's nothing in the cost raster for that cell. Or if there is a value there, but it's higher than the new value, it means that there was a previous path that was calculated along that section, but that path is more expensive than the one that's being written now. So the idea is if it finds a path through an area that is less expensive, it can overwrite what's already there because that's the better path now that it's found. And then once it does that, if it successfully overwrote the cell or wrote it to the cost raster, it'll put that in the process list, and then it'll do the same process to that point. And it will keep going until there are no paths along that that are less expensive than what already exists, or if it reaches the edge of the raster. Kind of complicated, but the point is you can move in more directions, or your slope value will actually correspond to the direction you're traveling instead of just assigning one value that is slope per cell. You can see here the difference between the aerial slope raster, which was made in ARC, and then a linear slope raster. And each color corresponds to direction of travel. So you can see that with the aerial slope, it's very much, you know, generally you travel in one direction to get back to your starting point, whereas with linear slope, there's a lot more variation in the way that you travel. So I actually have two examples of this. This is the first one. This is on a pretty large scale. So the aerial slope is in blue and the linear slope is in orange. The aerial slope path is smoother because the tool in ARC, it basically does the smoothing for you. But the input data is the same, so it's not like there's more information, but it's more accurate in terms of resolution. So that's about the same. The biggest diversion between these two is about 17 kilometers apart, which is, I think, kind of significant. There are some issues to sort out with the code. So the processing list, which is, you know, the list of coordinates that it needs to process to find the slope of the neighbor's score, isn't quite behaving like it should. I think it's just my formatting of the code that I need to work out. If that's something that I do end up doing. I also did a smaller scale test this morning. In the Catskills, so I have my starting point at kind of the base of this valley on the bottom right corner, and then the destination point is right near the top of Sliding Mountain. And then this is the GEM for that, and this is 1 arc second in comparison to the first example, which I think was 30 meter resolution, so it's a bit more, the resolution is higher. So the distance accumulation rasters, so this is, you have your starting point, and as you move further out, it basically gives you the quantitative cost of getting all the way over to this new cell. You can see that with the aerial slope on the left there, if you look at the bottom right corner, green is easier to travel to, or is less expensive, and the yellow is more expensive. You can see how that kind of follows the shape of the mountain there. So you have the ridge, which is not very expensive. You have the valley, which isn't very expensive, and then the slope in between is more expensive because aerial slope sees ridges and valleys as being less expensive typically. Whereas with the linear raster, you can see that it's a lot smoother because you can actually move across the side of the hills or mountains there. So it ends up being a lower cost. The back direction, which is the path of travel, you can see a similar thing to before. The path is a lot more varied in terms of the direction that you tend to travel. And you can also see with the aerial slope again, that pattern in the bottom right. It really follows or it really separates the ridge, the valley, and then the part in between, which isn't as much of a case with the linear slope. So this was the result here, which I thought was actually pretty good. Aerial slope is in green and then linear slope is in red. You can see that for the aerial slope path, it follows that ridge all the way up. Whereas with the linear slope one, it actually moves over onto the side of the hill and then travels across it, which indicates to me that it's working essentially. So I haven't gotten a chance to look at this too much because again, I ran it this morning. But I do think this was a pretty promising result. So For the future, I was hoping to keep working on this, and then I got the flu for 2 weeks. And, I ran out of time. So, the last time I worked on this was like 2-3 weeks ago, so. I'm a bit rusty on it already, and I have other things to do now, so I do not know if I will be able to keep working on it.
It's amazing how that happens, like a couple of weeks away from code you're writing and like really,
Yeah.
what was I doing? And it's all make total sense to me when I was doing it, and now I'm like, I don't know what's going on.
Yep.
Sorry you're sick, that's rough.
Yeah, it wasn't fun, but got through it, so. And that's why I missed like 2 lab meetings. So, on the DMLib units, they basically don't work with my phone, and I don't really know why. I can, connect to the unit can connect to my hotspot, it can pull up the connections. But I can't receive any corrections, over Mtrip. So there are 2 solutions that might work. One is to use a different phone altogether, which I'm gonna hopefully pick up my old one this weekend and see if that works. And then there's also the option of just putting a SIM card directly in the unit. And for reference, this is basically a GPS, to get location data. So we can use a SIM card directly to get access to those corrections. That's also something that could work. But that'll have to wait until after this weekend. And I think it makes sense to try with a different phone first.
I did try some post-processing on the little bit of data that I had, and I don't love it. You would think that you could post-process it better than you could do the RTK, but it's not always true. Because if that were the case, then we wouldn't have to worry about any connections. You just type around the thing and we figure it out. We
Be a
get
lot
back.
easier.
I mean, we could still try that, but I'm just not
Yeah,
super hopeful that it's gonna work. Anyway,
so we'll see. I did get it to work once, connecting to the unit over Bluetooth and then sending the corrections over Bluetooth. And then it never worked again. And even when it was working, the corrections were floats, not fixes, which means that I don't really know if they would have been useful in the first place.
substantially worse. It's like 0.5 meter accuracy instead of 0.02. So
Yeah.
yeah,
So the corrections and I are not on speaking terms right
okay.
now. So goals for next week, do something and just have it work. I think that would be wonderful. Look into alternative slope and non-slope cost factors for paths. And probably also look into the statistical stuff that you brought up in your presentation.
Okay.
Look into MealPie and the other tools around that. And then my fact of the week is about tooth and eye surgery, which removes a patient's tooth and inserts a lens into it. And after implanting it in a patient's cheek for about 4 months, doctors will remove it and implant it into the eye. It's used in cases of severe vision loss to restore sight.
I have to admit, I sometimes wonder if you're testing us, like, is it like this is so fantastical that like
It was invented in the 1960s by an Italian guy.
you swear it's true?
Yep,
All right.
check Wikipedia.
We played 2 truths and a lie with my 5-year-old daughter, but you could try that on us sometime. One of these facts that I was like,
Yeah.
That's great.
Maybe
Thanks.
I am,
Cool. Thanks, Dan.
so.
All right. Priyanka, anything this week? Okay. And Alana had to go. With everybody? Yeah. Like the end of the party, right? Hanging around.
Oh, those are.
So we need to get you flying, which is, did you say Monday and Tuesday?
Monday and Wednesday,
Monday.
afternoon is on free.
Okay.
Or Tuesday, would work only on before noon.
Okay.
At least 2.
Yeah.
Later.
Nice.
I think the best thing to do is probably for me to partner you with Buckman and Alana. Because so I'll send a message,
They got
we'll start a thread on Slack, we'll try to get that going. if it gets to the point where you just wanna collect some imagery, like, we can, Buckman always needs more training flights, so we can just have them do it.
Blue.
But you seem like you're pretty interested in learning to do it, so we can keep doing that. Yeah, I think we should be able to make that work.
Should we get this on the internet?
Looks good.
Yeah, it sounds good.
All right, well, thanks so much for coming. I know it's kind of a long thing, but once we get, maybe once we get some data collected, so you want to collect data of the Japanese knotweed.
Take a look at that little
And is it gonna be
pamphlet.
fine? Like my Japanese knot, I've got a little patch of it in my yard, and it's just like dried sticks. Like, is that, what would you want? Is there like a season? I don't remember at which point it started to grow last year. I remember it sprouting from the ground.
Yeah. It's when it like reprints something, it has to like shoot out the.
Check your drone and it's so.
Yeah.
Or like when it's just
If the drone is working.
Yeah, have it on.
So it's checking this out.
Okay, and it's on campus, you say?
Yeah.
See if you can get like where on campus, like, have Mark just like point it out on Google Maps and,
No, just I have to ask.
yeah, you don't have to ask him, and then, get the latitude and longitude, and then maybe we can take a look at it, like, do you think you can get that coordinates today?
I'll ask him about
Okay.
Really?
Then that's the spot that we would probably want to fly on Wednesday. We might as well, I mean, we can make it a training flight anywhere, but we might as well collect what we want to collect.
Yeah.
One of the benefits of drone imagery is the ability, I mean, people often focus on spatial resolution, like, which is good. Temporal resolution is kind of an underused aspect. So if we could like image it now, you know, probably a week from now isn't gonna matter. But like there are parts of the year, Mark and I have talked about this, of like, where like Japanese knotweed is like obvious, like it turns bright red and like, you know, it's there. So I think that would be kind of the interesting thing is to characterize like what it looks like, you know. You wouldn't do it every week probably, although the redness of it only lasted a couple of weeks, you know, so there was definitely like a sweet spot. And then kind of how it behaves at the end, but anyway. For answer, we'll try to fly your spot in. Okay, all right, thanks for coming.
It's okay.
And can I practice your name again? No, no.
Yeah.
Close. Thanks.
Have a good day.
No, so who did we bring?
You were, yeah, you were picking out.
Well, I think you explained it well, man. We still gonna have to sit down.
This is not-
We have to go over the detail. I tried to focus as much as I could, try to get, but I think we're still.
I don't have a great
understand.
way to explain it, which is part of the problem.
No, that's okay, we'll just have to sit down.
Yeah, go through the code probably, so that's why.
I can get a second, one of these. Like data twice as fast, there's a lot of trails out there. Alright, so-
Yeah, I don't think
Yeah.
it.
Would any of them be using the smaller units?
I mean, we could, it's just, I mean, that's a good point, right? Why, yeah, just use the other thing, yeah. Yeah, it's probably the thing to do, yeah. I did like this system only because. It's just like
were gonna frame,
very.
but I was gonna
sophisticated
throw that.
and very-
That wasn't actually.
Yeah.
Oh.
Right.
Sorry.
It's probably table now.
People actually always want South America.
I don't know why you started.
No, yeah, those two. That's okay.